faithfully delivering value and exploring great books worldwide. Hi, this is Sally's Book Talk. Today I'm going to interpret the book Agatha's Poison for you. Agatha Christie, the queen of detective fiction, is one of the most successful writers ever. She authored classic detective novels like Murder on the Orient Express and Death on the Nile, with her total book sales ranking third, only behind the Bible and Shakespeare. Characters she created, like the great detective Hercule Poirot and Miss Marple, are household names in detective fiction history. Agatha was expert at using poison in her works. Out of over 80 books totaling more than 200 crime stories, poison was used as a murder method over 100 times. For example, in The Pale Horse, victims died from common illnesses like pneumonia or cerebral hemorrhage, but they all shared a symptom: hair loss. And this was precisely due to poisoning. Additionally, poisons like arsenic, belladonna, nicotine, opium, and veronal often appear in Agatha's works, and she always succinctly describes their effects and symptoms. Agatha's knowledge of poisons is so solid that some pathologists study her novels as real poisoning cases. This stems from her experience as a hospital volunteer during World War I. At that time, she was recommended to work in the hospital pharmacy and passed the assistant pharmacist exam in 1917. When Agatha was studying for the pharmacist exam, there's a little story about her tutor, the pharmacist. Mr. Pye was a bit careless. Once, while preparing medicine, Mr. Pye mistook a 1% dose for 10%, turning a remedy into poison. It was too awkward to correct him directly, so Agatha pretended to slip, spilled the medicine, and stomped on the bottle, cleverly averting a medication disaster. Today, this book, Agatha's Poison, will take you into Agatha's world of poisons. The author is British science writer Catherine Harkup. She has extensive research in toxicology and is a big fan of Agatha. In this book, the author combines real cases and novel plots to vividly interpret the key poisons used. Agatha used many poisons in her novels. Based on how they affect the body, they can be roughly divided into 4 categories. The first type enters the bloodstream and destroys cells throughout the body's organs. The second type has a strong destructive effect on heart function. The third type damages the nervous system, while the fourth acts on the digestive tract, causing fatal gastrointestinal issues. Now, let's explore their stories one by one. The first category of deadly poisons destroys cells throughout the body's organs, with cyanide and ricin as prime examples. First, cyanide appears in at least 10 novels and 4 short stories by Agatha, killing 18 fictional characters. This terrifying poison appears in stories through injections in drinks, added to bromides, or hidden in cigarettes. When cyanide enters the body, it blocks cells' energy source, causing them to shut down and leading to rapid death. Most human cells contain structures called mitochondria, which act as cellular engines. Mitochondria are crucial, especially for heart and nerve cells, relying on hemoglobin to deliver oxygen that reacts with glucose. However, cyanide group displaces oxygen and binds to iron in hemoglobin, preventing mitochondria from getting energy. If someone ingests lethal amounts of cyanide, they can die suddenly within minutes. Symptoms include dizziness, rapid breathing, vomiting, drowsiness, and accelerated heartbeat leading to unconsciousness. While rare cases may last longer, death usually occurs within 4 hours. Cyanide has many forms existing naturally and synthetically, with toxicity determined by how tightly the cyanide group bonds to other elements. Take hydrocyanic acid. Its weak hydrogen bond lets cyanide easily escape, so just 50 to 150 milligrams, about a paperclip's weight, can kill an adult. Methylcyanide is far less toxic. Its stable bond prevents cyanide release, so most methylcyanide gets excreted before causing harm. Many common foods contain cyanide, like peach, cherry, apple, and bitter almond pits. Their fruit pits contain a compound called amygdalin, which is easily metabolized by enzymes in the small intestine, releasing dangerous hydrocyanic acid. So, eating these fruit pits is equivalent to ingesting cyanide. However, there's an issue with lethal dosage and toxin conversion rate. Take apples, for example. You'd need to eat 200 grams of apple seeds, which is thousands of apple cores, and chew them thoroughly to release enough cyanide to be lethal. But in bitter almond pits, the amygdalin content is much higher than in apples. A small amount of bitter almond pits can be fatal. Note, we're talking about bitter almond pits, not the nuts we commonly eat, like sweet almonds or pistachios. Another food high in cyanide is cassava. It looks somewhat like a yuccan root. The cassava flour used by concubines to poison each other in the TV series Empresses in the Palace comes from it. People in tropical regions love to eat it. One type, bitter cassava, has high cyanide content, 1 gram per kilogram. So raw cassava must be ground into flour and soaked in water for a long time before use. This is cyanide removal processing. Eating improperly processed cassava may not kill you, but it can cause thyroid enlargement and nervous system damage. This disease is called Konzo disease. The characters are Kong, like Confucius, and Zuo, like assist. People with this disease experience problems like unsteady walking. Konzo disease is irreversible and can be fatal in severe cases. Besides natural foods, cyanide also appears in synthetic compounds. For example, something called Prussian blue was used in photo development, which is also a cyanide compound.
It's not very toxic on its own, but when acid is added, it forms highly toxic hydrocyanic acid.
Insecticides also contain cyanide. Small amounts dissolved in water or weak acid form hydrocyanic acid, used to kill insects. In the early 20th century, some U.S. prisons used gas chambers for executions, releasing toxic gas from sodium cyanide and sulfuric acid reaction. Cyanide is so toxic, is there an antidote? Antidotes exist, but they are minimally effective. The principle of detoxification is to provide another active site that binds to cyanide, allowing oxygen to bind to iron and hemoglobin smoothly. Today, using this principle, many antidotes for cyanide have been discovered. For example, hydroxycobalamin is a natural form of vitamin B12, but antidotes race against time. Cyanide destroys hemoglobin in the blood far too quickly. 95% of cyanide poisonings still lead to death, truly earning its reputation as a terrifying poison. Besides cyanide, another chemical that kills by destroying cells is ricin, produced by the castor plant. Every part of this plant is toxic, with the highest ricin concentration in its seeds. In Agatha's short story, The House of Lurking Danger, the victim eats a fig sandwich laced with ricin during afternoon tea. The poisoner extracted the ricin from castor plants in the garden. Ricin disrupts cellular metabolism, causing body cells to die and ultimately leading to organ failure. Human cells are like factories, with various structures acting as workshops, each performing its own function. The factory's gate is the cell membrane, controlling what enters and exits the cell. Ricin easily enters cells and permanently shuts down ribosomes, which specialize in making new proteins and replicating cells. Once ribosomes stop working, the cell dies. When cells in human organs die en masse, it causes massive bleeding and organ failure. After ricin poisoning, symptoms appear within 6 hours. First comes a burning mouth sensation, then nausea, vomiting, convulsions, bluish skin, progressing to mental confusion, bloody urine, and limb twitching. Death follows, with the entire process taking about 3 to 5 days post-poisoning. 5 to 20 thoroughly chewed castor seeds can kill an adult, yet oil pressed from these seeds is consumed as a laxative. This is because ricin dissolves in water but not oil, so castor oil contains minimal toxin. Instead, its components inhibit intestinal fluid absorption and promote bowel movement. Thus, it's a natural laxative. For safety, castor oil is heated to 80 degrees Celsius before use, as heat alters seed proteins, deactivating the toxin. Most ricin poisonings occur from accidental seed ingestion, but fatality is only 5% since the hard shells pass undigested unless thoroughly chewed. But specially refined high-concentration ricin is even more lethal than the same quantity of arsenic or cyanide. Subcutaneous injection of less than 1 milligram of ricin can kill an adult. Even inhaling ricin dust is equally deadly. The lethal dose for oral ingestion is somewhat larger. but it still only takes 100 milligrams. In 1978, a real ricin murder occurred in the UK. The victim, Markov, was an outspoken opponent of the Bulgarian government, blacklisted by authorities. One day, while waiting for a bus, he suddenly felt a sharp pain in his thigh. Nothing seemed unusual except a man bending to pick up an umbrella. That same night, Markov developed high fever and vomiting. The next day, doctors found only a needle mark with slight inflammation on his leg. X-rays showed nothing abnormal. By the third day, Markov deteriorated. Rapid heartbeat, low blood pressure, elevated white blood cells. All infection signs. Additionally, he had difficulty urinating and began vomiting blood. Soon, fluid filled Markov's lungs until cardiac arrest. Autopsy showed acute blood poisoning from the leg puncture. A tiny pellet, just 1.7 millimeters diameter, riddled with toxin release holes, was found in his leg muscle. Medical investigators determined only ricin could kill with such microdoses, delivered via pellet shot from a modified umbrella. Currently, no highly effective ricin antidote exists, though vaccines can prevent poisoning. But this vaccine's effectiveness lasts only months. That concludes the first category, poisons that kill by destroying human cells. Next, the second category, poisons that disrupt heart function. Representatives include foxglove and aconite. First, foxglove, Digitalis purpurea, extracted from digitalis plants commonly called foxgloves, with over 20 species found across Europe, Asia, and Oceania. Its colorful tubular flower clusters are visually delightful. Painter Van Gogh depicted Dr. Gaucher, who treated his epilepsy, holding foxglove flowers in 2 portraits. Foxglove plants contain varying levels of toxins throughout, acting as a deterrent to animals that might eat them. Mammals poisoned by foxglove experience skin allergies, fainting, headaches, and severe heart effects, including heart attacks. Yet foxglove is both poison and medicine. In controlled doses, it effectively treats edema caused by weakened heart function. In Agatha's famous novel, Appointment with Death, the universally hated Mrs. Boynton dies from foxglove poisoning. Mrs. Boynton had heart disease. She died quietly under intense sun, nearly ruled a heart attack, but Detective Poirot found a hypodermic needle mark on her arm. Through deduction, Poirot concluded she died from lethal foxglove overdose. Its symptoms mimic heart attacks.
Foxglove causes complete cardiac paralysis, leading to death.
In patients with atrial fibrillation or arrhythmia, electrical signals between heart sections become chaotic. This chaos creates irregular pulses, while foxglove compounds regulate heart rate by weakening electrical signal transmission. In the early 20th century, some U.S. prisons executed inmates using toxic gas from sodium cyanide and sulfuric acid reactions. Cyanide is so toxic, is there an antidote? Antidotes exist, but they're minimally effective. Detoxification provides alternative binding sites for cyanide, freeing oxygen to bind with hemoglobin's iron. Today, this principle has led to many cyanide antidotes. Hydroxycobalamin, a natural vitamin B12 form, works, but antidotes race against time. Cyanide destroys hemoglobin too quickly. 95% of cyanide poisoning still prove fatal, truly a terrifying poison. Besides cyanide, ricin also kills by destroying cells, produced by castor plants, fully toxic with highest concentration in seeds. In Agatha's short story, The House of Lurking Danger, a victim eats ricin-laced fig sandwiches during afternoon tea. The poisoner extracted ricin from castor plants in the garden. Ricin disrupts cellular metabolism, causing body cells to die and ultimately leading to organ failure. Human cells are like factories, with various structures acting as workshops, each performing its own function. The factory's gate is the cell membrane, controlling what enters and exits the cell. Ricin easily enters cells and permanently shuts down ribosomes, which specialize in making new proteins and replicating cells. Once ribosomes stop working, the cell dies. When cells in human organs die en masse, it causes massive bleeding and organ failure. After ricin poisoning, symptoms appear within 6 hours. First comes a burning mouth sensation, then nausea, vomiting, convulsions, bluish skin, progressing to mental confusion, bloody urine, and limb twitching. Death follows, with the entire process taking about 3 to 5 days post-poisoning. 5 to 20 thoroughly chewed castor seeds can kill an adult, yet oil pressed from these seeds is consumed as a laxative. This is because ricin dissolves in water but not oil, so castor oil contains minimal toxin. Instead, its components inhibit intestinal fluid absorption and promote bowel movement. Thus, it's a natural laxative. For safety, castor oil is heated to 80 degrees Celsius before use, as heat alters seed proteins, deactivating the toxin. Most ricin poisonings occur from accidental seed ingestion, but fatality is only 5% since the hard shells pass undigested unless thoroughly chewed. But specially refined high-concentration ricin is even more lethal than the same quantity of arsenic or cyanide. So when you know subcutaneous injection of less than a milligram of ricin can kill an adult, even inhaling ricin dust is equally deadly. The lethal dose for oral ingestion is somewhat larger, but it still only takes 100 milligrams. In 1978, a real ricin murder occurred in the UK. The victim, Markov, was an outspoken opponent of the Bulgarian government, blacklisted by authorities. One day, while waiting for the bus, he suddenly felt a sharp pain in his thigh. Nothing seemed unusual except a man bending to pick up an umbrella. That same night, Markov developed a high fever and started vomiting. The next day, he had a doctor examine the wound on his leg, which showed only a needle mark with slight inflammation. X-rays revealed nothing abnormal. By the third day, Markov's condition worsened. His heartbeat quickened, blood pressure dropped, and white blood cell count rose, all signs of infection. Additionally, he had difficulty urinating and began vomiting blood. Soon, fluid accumulated in Markov's lungs until cardiac arrest. Autopsy revealed he died from acute blood poisoning originating from the puncture on his leg. And a tiny pellet, just 1.7 millimeters in diameter, riddled with holes for toxin release, was found in his leg muscle. After medical investigations, it was determined that only ricin could kill with such a microdose, and the pellet was shot from a modified umbrella. Currently, there's no highly effective antidote for ricin, but vaccines can prevent poisoning. However, the vaccine's effectiveness lasts only a few months. That concludes the first category of poisons that kill by destroying human cells. And next we'll discuss the second category, poisons that disrupt heart function. Representatives include foxglove and aconite. First, foxglove, Digitalis purpurea, extracted from digitalis plants, commonly called foxgloves, with over 20 species found across Western Europe, West Asia, Central Asia, and Oceania. Its colorful tubular flower clusters are visually delightful. Painter Van Gogh created portraits of Dr. Gachet, who treated his epilepsy, showing the doctor holding foxglove flowers. Foxglove plants contain varying levels of toxins throughout, deterring animals that might eat them. Mammals poisoned by foxglove experience skin allergies, fainting, headaches, and severe heart effects, including heart attacks. Yet, foxglove is both poison and medicine. In controlled doses, it effectively treats edema caused by weakened heart function. In Agatha's famous novel, Appointment with Death, the universally hated Mrs. Boynton died from foxglove poisoning. Mrs. Boynton had heart disease. She died quietly under the scorching sun, merely ruled a heart attack, until Detective Poirot found a hypodermic needle mark on her arm. And, well, through deduction, Poirot concluded Mrs. Boynton died from lethal digitalis overdose. Its symptoms mimic heart attacks. Digitalis causes complete cardiac paralysis leading to death. In patients with atrial fibrillation or arrhythmia, electrical signals between heart sections become chaotic. Let's break it down. Muscle movement requires nerve signals passing between neurons until reaching muscles to trigger contraction. In this process, a chemical called glycine gets released. It acts like a brake system, controlling nerve signal release to prevent excessive muscle contraction. When strychnine floods the bloodstream, it blocks glycine's control, causing the nervous system to wildly fire signals to muscles. Muscle contractions lengthen, causing victims to arch forward or convulse in opus totanos positions. This occurs because back muscles are stronger and receive more intense nerve stimulation. Additionally, strychnine affects cerebral cortex neurons, creating hyperactive brain activity. Terrifyingly, victims remain fully conscious throughout, aware of their entire poisoning process. Centuries ago, strychnine served as pesticide. Ancient Indians even detoxified it for blood pressure medication. However, by early 20th century, it largely disappeared for medical use. In Agatha's debut, The Mysterious Affair at Styles, the victim dies from strychnine poisoning. Agatha reused this poison in 4 later novels and 5 short stories. Strychnine poisoning symptoms appear within 30 minutes. Initial symptoms include muscle stinging, twitching, nausea, and vomiting. Then comes severe muscle spasms, body contortions, and ultimately death by suffocation after repeated violent convulsions. In real cases, strychnine is the 3rd most common poison, after arsenic and cyanide. Victims often die after ingesting strychnine-laced potions or pills. There's no specific antidote, and treatment must race against time due to rapid onset. Morphine can relieve pain and calm nerves, but muscle relaxants like diazepam are crucial to control violent convulsions. Combined with artificial respiration, this method helps gradually eliminate strychnine without side effects. All right, that covers the 3rd category. Now for the 4th category of poisons, they attack the digestive tract, causing erosion, vomiting, and other symptoms. The representative poison is phosphorus, a familiar chemical element. When combined with oxygen to form phosphoric acid, it becomes essential for human life. But phosphorus has a dark side. White phosphorus makes bombs, rat poison, and matches, all deadly.
Phosphorus has several forms distinguished by color: white, red, purple, and black.
In the 17th century, white phosphorus was first discovered by German chemist Brand during an awkward gold-seeking experiment. He boiled putrid urine, searching for gold, producing a paste-like substance. After mixing 2 extracted compounds, white smoke rose. Brand collected it, and it condensed into waxy white solid. Though not the gold he sought, this self-illuminating substance became phosphorus, a new element. Its Greek name means light bearer. White phosphorus, P4, is insoluble in water but soluble in oils, yellowing with age. Hence its nickname, yellow phosphorus. It's highly reactive, especially with oxygen. Stored underwater, it releases intense heat and smoke when burned, used in incendiary bombs and smoke screens. Its cold glow inspired attempts at lighting devices, but all failed. Phosphorus was too flammable and produced foul garlic-like odors during processing. However, white phosphorus's flammability was utilized in the 19th century when matches made from it became common household items across Europe. But white phosphorus matches were unsafe. Even leaving a box on a windowsill could cause spontaneous combustion from sunlight exposure. Not only were these matches dangerous to use, but their production caused chronic poisoning in workers. About 20% of matchmakers developed phossy jaw necrosis. It started with toothaches, then tooth loss, followed by swollen gums, jaw, face, with excruciating pain, eventually corroding soft tissue and bone. The only treatment was removing the rotted jawbone and replacing it with an artificial one. Untreated, the poison would ravage internal organs. Studies show half of sufferers chose suicide due to unbearable pain and foul odors. In Agatha's dumb witness, the murderer used phosphorus. The elderly victim's symptoms mimicked jaundice and liver disease relapse. Liver disease often causes jaundice, yellowing of the eyes, sclera, and skin. In truth, the woman was poisoned with phosphorus, and jaundice is also a phosphorus poisoning symptom. The killer exploited this to fake a liver disease death. Earlier, we mentioned chronic poisoning in workers. How does phosphorus kill quickly?
It's about dosage.
Just 100 milligrams ingested is lethal. White phosphorus burns through esophagus and stomach walls like skin, causing massive bleeding and vomiting when mucosa damage occurs. Meanwhile, phosphorus entering the bloodstream accumulates in the liver via the intestines. The liver detoxifies by dissolving toxins in water for urinary excretion. Since white phosphorus isn't water-soluble, liver enzymes chemically alter it for elimination. But excessive reactions damage liver cells, causing enlargement, jaundice, and eventual detox failure. Once detox collapses, organs like kidneys become toxin-exposed, usually fatal within 3 to 4 days. In this Agatha novel, the victim died of liver failure after eating curry rice laced with large amounts of phosphorus poison. Curry rice was chosen because its strong smell masks phosphorus's garlic odor, and greasy food enhances phosphorus absorption into the bloodstream. All right, we've covered 7 common poisons in Agatha's novels that kill by damaging cells, nervous system, heart, or digestive tract. However, poisons can sometimes become antidotes, like physostigmine from Agatha's Crooked House, which causes cramps and slowed heartbeat, but treats poisoning from atropine, strychnine, and nux vomica, and also tetanus. Similarly, atropine, itself a poison, is an antidote for digilast poisoning and many toxic alkaloids and organophosphates. But in the labors of Hercules, it appears as a terrifying poison causing hallucinations, severe rashes, and swallowing difficulties. And Paracelsus, the Swiss physician who founded toxicology, said, "All things are poison, and nothing is without poison." Whether something is deadly poison or life-saving medicine depends on context and dosage, a complexity mirroring human nature. As Agatha Christie wrote in Murder on the Orient Express, "There's no absolute justice, but human nature always offers redemption." That concludes our interpretation of Agatha's Poison. Reading notes are below the audio. See you next time.